You're able to hear me?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. Okay. How many are there? Four, Srinath? Joseph? How many are there? Only you two.
Yes, sir.
Srinath and Joseph.
Sir, Dr. Srinath, Dr. Joseph, and you, sir,
Yeah.
so far.
Srinivasan, நீ கிளம்பு. I mean, Srinath is there.
Yes, sir. Yes, sir. நான் வெறும கேட்டுட்டு தான் இருக்கேன், sir. No problem.
No problem, because I don't want to, hold you on to this thing. So,
இல்ல, sir. No issue, sir. Not at all. Thank you, sir.
Sir, again I called him back, sir. He said he is in a meeting. He will call back. That's a message I'm sure.
sure, okay, he will do
Yes,
that.
Yes, sir. So Dr. Arjun told he is having running temperature, sir. This morning for the talk itself, he told, sir.
Oh yeah, I think everyone. My wife is running temperature. Everyone has temperature. I have, my throat is slightly bad. Came out of fever. She's having 100. I think everyone in the city is having.
Yes, sir. I also are having a bit feverish now.
Yeah, everyone is
Yeah.
having that.
I guess the season changed, sir. Now the summer is setting in. Like,
I think we should have asked this question to Pedro. Okay, what is the virus that is going around?
Sir, we must ask China, sir, not Mr. Pedro.
But
What is they have in the pipeline?
This is not fair. This is not Chinese virus. This is local virus. We'll wait for some time. Let's see what. I think today is unscheduled. I don't know.
அப்புறம் 5 சேர் இருக்குமே, ஆபீஸ் சேர்.
Office chair with
அப்போ பாத்தீங்கன்னா அதுவும் தனியா ஆர்டர் போட்டணும். 5 நம்பர்
5 numbers.
ஆமா.
ராமனுக்கும் கொஞ்சம் மேத்ஸ் கத்துக்கணுமா? ராமன், டிஃபரன்ஷியேஷன், இன்டகிரேஷன்.
Sorry, sir. Sorry. Oh, sorry, sir. By mistake, I muted.
எக்ஸல் பார்த்துட்டு இருக்கேன் சார்.
ராமன் பரவாயில்ல. ராமன், நீங்க உட்காருங்க.
இல்ல சார், இல்ல.
Yes, sir.
ஏற்கனவே MBA ஸ்டாட்ஸ் படிச்சு 4 அட்டெம்ப்ட்ல பாஸ் பண்ணேன் சார்.
இது இப்ப கிளாஸ் அட்டெண்ட் பண்ணுங்க. ஒரே அட்டெம்ப்ட் தான். அடுத்த லெவல்.
Yes, sir.
Yeah. There's no one else, man. We'll wait for another. Joseph, sorry that people have not joined. We'll wait for another 5 minutes.
No problem, sir. We can. Yeah.
Say what we'll do is you ask questions. If there are any questions you or Srinath won't have gone through it because I've been torturing him for quite some time. So he's
Sir,
working
please, sir,
tirelessly for the department.
please don't say that, sir, please, sir.
No,
I
no.
just had the privilege to audit the course, sir. Please, sir, please, sir.
See, Srinath, anyway, just to slight digression. So I talked to that guy. He's very enthusiastic, that Excense guy. So
Yes, sir. Yes, sir.
he said he will be very interested and he will give that.
Sure, sir. Sir, Dr. Shanti madam has joined now, sir.
Yeah.
Thanks, Srinath. I've joined.
Yeah. Dr. Shanti, we're waiting for others. There's no crowd.
Okay.
So if there is no crowd, we may have to cancel the class because this is an important class.
Okay.
But we'll wait for another 5 minutes.
Okay.
Problem is, I think this is slightly unscheduled class. People may have some other thing. I don't know. That's the problem. We'll wait for. Sorry. Do you have any questions so we can discuss? Joseph, Srinath, or Dr. Shanti, if you have any questions, we can discuss. If you have doubts.
Okay. What I had, I mean, you had asked us to look at the code, but I feel according to the individual person who is helping, the code also, the way it is written also varies.
No, the problem is for the same uh, you know for the same purpose or function, there can be different codes or different functions that can be used. In other words, codes can never be unique. So many times, so that would change, and so that is we have to look at that. But what is more important is to understand each line of code. That is what is more important, because the codes, if you see, they will, they will change in the sense depending upon the way it is written. That is all. So it would be. Let's take now. I'm just looking at how it's written. 1 second. I will take a code. We can explain that. Okay. I'm going to share my screen just to show you how do we interpret it. Are you able to see my screen?
No, not it.
Not yet, sir.
Is it okay?
Visible, sir. Yes, sir. We are able to see.
Yeah. So let's take a very simple program and interpret. So how do I interpret it? First of all, thousands of commands. That's why I resorted to ChatGPT. So ultimately, there will be 50 commands which will be useful to you, or 50 lines that will be useful to you. How do I do this? Best way is to cut and paste it ChatGPT, ask it to explain. It will explain. So from now on, after today or next class, what you can do is you can see what I need to do. Let us that is on a flow chart basis. So now let us look at, see what I did in the last class, that I took 5 functions. If you remember, I took some functions and then I wrote the functions and then I plotted the functions and then took their derivatives, okay, and plotted. So this is what I did, right? You remember that? Okay. Now, so this is the values I gave. A is equal to 1, K is equal to 1, beta is equal to 1, A1 is equal to 0.25, A2 is equal to 0.3. So, 0.03. So this is what I get. Then I have to have a range of C which I have to calculate. A range of C. That is, the range is from 0 to 5. What the range I have chosen. So 0 to 5. Lim space. What is lim space? It is a linear space. It simply means that from 0 to 5, take 100 intervals from 0 to 5. So point at 5 divided by 100 is each of these intervals. Okay. So that is what this means. So which means that not 0.05 is the interval between 0 and 5. Okay. Then the next commands show me the expressions. So what is linear absorption? The expression. Saturated absorption expression. Like that, I have all these things. So next thing is, I am plotting figure 1. Okay, that is the heading. Hold on. What is hold on? I'm going to plot 6 of them. So when I'm plotting 6 of them, plot first graph, hold on to that graph. Don't wipe it out. That's what it means. Hold on to that graph. Then plot 1, second one, third one, fourth one, fifth one, sixth one. So I have plotted all these things. Clear? Now, after I plot, so what is that I am plotting? It is C versus the first one. C, this is the X versus linear absorption. That is Y. Right? This is the line, color, black. Line width of the line, which is 2 mm. So this is how you interpret. So once you have a code and start interpreting tomorrow, you want to write your own code, you know how to plot it. So you can easily say what should be the plotting. Clear? So up to this, I'll stop here. Do you understand this? Any questions on this?
Space the range. It's always it's a definition for the range.
That range where my cursor is there, that one. So lim space is linear space. That's what is the short form of linear space. Linear means it is from 0 to 5. It is increasing by a specified amount. It's linear. So it's by a specified. So every jump is the same. That's what it means. So it is 0, 0.05, 0.1, 0.15, 0.2. That is what is called linear space. So there are 100 of them from 0 to 5. That's what it means. Is that clear? So if I now change 5 to 10, which means that my C value will vary from 0 to 10. So if I now run it, so now it is, look at this. It is from 0 to 5. You see this here. Now if I now change it, if I now change it to 10, I can keep 100 the same or I can make it 200. Let me not worry about that. I'll just show you this alone. So now see here, it has become 10. Now this, after plotting, I think I'm not interested up to 10. So I can put it up to 3. So it can be up to 3. Then I get better view of this whole thing and so on. So that is the derivative of these functions. So is that clear? This is what is the range of C in x-axis. That's what it means. So I've written down all that function. So how is this? Multiplication is star, division is this. Okay, then to the power of is this, and so on. Now, is that clear? That's the next thing. Now the next step is you see some dot here. A star with dot divided by. So what is that C dot? I don't have it at every place, but at some places I have. Where do I have it? I have it when I follow that C with an operation. Now, what is the operation here? It is division. That is the division. So why do I put C dot? That is because there are a number of values of C. C is not one value. So C is an array of values. 0, 0.05, 0.1, 0.15, and so on. So a number of values. So when C is a number of values or is an array, then I put one dot here. If I don't put a dot, it will take it as one value of C. If I put a dot, so it means that, hey, a number of C's are coming. So what does that there? I have already defined them here. So you'll see before the division. Here I don't put dot because already I've defined this function and there's nothing else after that. There's no function. So C dot here, okay, dot, because this whole thing is going to become an array divided by and so on. So you can see that a dot simply means before an operation simply means that the number of array points are going to come. Is that clear? That's how we define it. So AC by K plus C, this expression. AC by K plus C. Okay? That is the saturated absorption. So C being number of values, I got C dot. Okay. So then we will go, hold on, as I just now told you. So these are the plots. We just now saw the plot. Then add legends. Legend. What is that legend? So you can see it here. Okay. You can change this position also. So I have put it as west. You will see it west here. So you can change that. You can try it out. You know how, depending on the graph, you can put it as east, north. So the advantage is that here, if I start typing itself, it will give you west or west outside. So I will put west outside. Let's see what happens when I say west outside. Okay, that is for, actually I'm plotting that for this thing, so you see here. This is the west outside. Okay, outside. So I can plot it the way I want it. West outside, east, so. Okay. So this is actually, I'm plotting the slope here. Okay. So I plotted the functions. Okay. So X label, sorry, I missed it. X label, Y label, title, grid on. I'm putting the grid and then hold off. So here also I can write, say for example, just outside and then draw it. That's the slope. That's the function. So that's the function, absorption function. So now that's what is best. So then I'm calculating the slope of these functions. Now, how did this know? Because I have already defined it like that. In fact, the ChatGPT differentiated it for me and gave it as a slope. So that is why the slope is already given here. I asked ChatGPT to write it, so it's written. Then I plot all the slope. Okay, I've added the legend, explainable, y-label, triangle, over. Is that clear? Dr. Shanti, is it clear?
All this is clear, except here in this plot slopes, like you're assigning one variable to the name like B, G, and all to that. Is it so?
No. This is the color.
Okay.
The
Oh,
color
blue.
of the now if I run. So the color of this one. See, saturated plot.
Okay.
Here,
Okay, it's blue,
linear
green, and
absorption.
okay.
So I'm giving colors for this. So those colors are given here. Okay. So blue, green, red, magenta, and so on. Okay, K is black. That's the colors. Clear? So the width, line width is that thickness of that line.
Yes, thank you.
Okay? Clear?
Yes, thank you. Yes, thank you.
Now let's look at another problem. So let's understand this. Okay. So now I'm plotting this one. We saw how the mass varies. So sims t, that means what is that? So it's a symbolic operator. That means that it is like an algebra. Treat it as an algebraic equation. Ax plus b, something like that. Okay. Don't ask me the value right now of a or x and so on. So symbolic operator. So this is symbolic operator. And this is symbolic. Right? I'm telling MATLAB sims t means I'm going to use t as a variable to do further things. That's what it means. Okay. In other words, I am going to use this function t or t. I mean, a function which is based on t. I'm going to use it for differentiation. So, for example, I'm going to write mt is equal to vt into rho t. Clear? That is volume into density is equal to mass. I'm just writing it. Now, since t is my symbolic, so I can now what does it mean? It means that I can operate on t. I can operate like I can differentiate it with respect to t. So I have told the system is symbolic. So dm by dt. I'm just writing dm. I can't write that by. That's not allowed. So I'm writing it like this. I'm telling now differentiate this function here with respect to t. This is valid only if I had given here simply. Okay. So differentiate this function with respect to t. That's all. I'm asking you to differentiate. You are telling in MATLAB you are here. You won't differentiate. So it is differentiate. Is that clear? Now, for example, here is your difference. In the last program, we wrote as linspace. You remember? We wrote it as linspace. Yeah. So I said that from 0 to 3 is divided into 100 different, in a gap of 100. That means 0.5, 0, 0.05, and so on. Divided into steps of 100 equally. That's why it's called linear space. Now let's look at here. There is a small variation. This is why one person to another person the program varies. So look at this now. 0 colon 0.1 colon 10 time range. So t varies. How do you read this? This is another way of writing the same thing. T varies from 0 to 10 with an interval of 0.1. This is what same expression. In space, Same expression I can do it with another command. Colon command. 0 colon 0.1 colon 10. So it's the same thing. I can do it like that. Is that clear?
Yes, sir.
So Dr. Shanti, this is what it is. So another fellow writing it, he can write it in a different fashion. So codes are never the same. Okay, each one develops a style. Now let's look at the next step. Now this is a symbolic operator. The symbolic operator cannot be plotted. Okay, I want to plot. Then I have to convert it into numerical operator. Okay, that's what this does. So double, let's not worry about it. Double means numerically, very precisely I can calculate. That's what it means. Number of bits that are used is higher. So now I already have this from here. T and time range. Plot this, and time range. Okay. By this substitution, which is double. Then I get the figure, I get the mass rate of change. Let's see what is the color. The second derivative. Okay. Oh, sorry. Yeah, that was my cursor was in another place. Sorry about that. So you see red because red here, line with this two, all those things. So this is an expression. This is very important because I can't plot a, a symbolic function. So I have to convert it. So this is what is that function. So now look at this. So this is the symbolic expression is now converted into a function, a value rather. So that's the time range and it's a value. If I don't do this, it won't know how to convert a symbolic operation into a value. So in other words, this command substitutes t into the symbolically operated dm by dt. What it means. What we found out symbolically by dm by dt, put it there. That's what it means. Clear? And then I can calculate, or I can plot, and that's what I did. Any questions? So you see here also, the same thing. Once you know one pattern based technology. So, yeah, I'll give you 2 minutes to look at this code. See the connection between this code and the previous code. So, Shanti, you're following this? So this is the expression.
This, okay, you meant this expression of this.
So it's a drug concentration with time. Now if you get this, say, some of the brochures give it, you can plot it beautifully. So when is the concentration maximum? That's the question we are asking. Right? So when is this maximum? Okay, we'll do one thing. You just see it. If there's any doubt, ask me. We will do a small problem. You might get into difficulty, and then ChatGPT itself will correct. Right. We haven't done a few things. I think I will take some time because the people have not yet come. So we will do one problem, and but anyway, we will, we will do slightly more theory, right? So we know how to calculate maximum and minimum, right? I mean, even if we don't know, we have our chat GPT, and we have beautifully. See, one of the problem is uh, side effects of medicine, okay, and percentage cure. So now let's take a function, the probability of cure. So you are uh, you want to have this dosage, okay, to be taken. So I'll just come out of this and write it down. So that's my cursor. Okay, I'm going to share. Where is my notebook? Oh. So let us say, let's write a function, and you guys can do this problem. So let's say that there's a probability. Let's say that X is the dosage of the drug. These are all real examples I'm taking. Dosage of some medication. So after doing trials, guys come and say the probability of cure is equal to root of X divided by 1 plus X. Okay, this is the probability of cure. Right. So I want what dosage maximizes the probability, because if I give a lot more dosage, I may get into side effect. I want to now determine what is the best dosage I can give to a patient. This is the question. Maximum dosage so that probability of cure is the highest. That's the question. So how do you do this problem?
Find the maximum
Maximum of what?
of the function p of x.
P of x. Maximum of the function P of x. Okay. So can you get the help of ChatGPT? Write it. We'll give 2 minutes. And get what is the maximum value. If you want to do it analytically, it's a headache. Best just to plot it and ask MATLAB to give you an answer. So, Shanti, please, you also try, put it in ChatGPT. Copy and paste.
So the maximum is,
Yeah.
sorry, it's just deriving still. One, sorry. It says, oh God, it's finally a very
No, you plot it. It is a complex function if you want to do it with hand.
Okay, the maximum value of P of X is, I mean, P of 1, it says. P of 1 is square root of 1 by 1 plus 1, that is half.
Half. Yes. So, very good. Let me plot that. Let's see.
I'll put it as.
Uh, I lost that program. 1 second. Just give me a second. I'll cut and paste it. I'll show you. Okay. I'm going to come out of this and then I'm going to go to my other computer. So you're able to see my screen?
Yes, sir.
You're able to, yeah, right? Yeah, I think I should be able to see the screen. Yeah, I'm able to see the screen. So look at this. So I just asked it to plot. There was one mistake. I corrected it. I asked it to correct. So this is how it looks like. So dosage of 1, whatever the unit is, gives a probability of 0.5. That's what Dr. Shanti is telling. Fantastic. That's what it means. So 1 and the probability is 0.5. That's what you are telling, right?
So it says the maximum value of half at X is 1.
Yeah. So maximum value is half, 0.5. And it exists at 1. That's all. I'm only plotting it to show what you said is correct. You can see that graph. Is it clear? So this is the answer it is writing here. You can see it. I'll just. Oh, that is the code. So you can see this. So the maximum value of P is 0.49999. That's 0.5 at X is equal to 1.01. So that is the probability is only 0.5 and the dosage is X is equal to 1. So you can see that if you give higher values, this probability is not going to increase, but there may be other side effects. So, Santi, is this clear? So you've done it very well, very good. That's a good example. Any questions? No questions? I have a, you know, Dr. Sundar is not there. I have one very good example from cardiology, but unfortunately he's not there. Quite complex. So maybe when he comes, we will do that in the next class. Okay. Now, the other things are, what are the, I mean, what are the other functions that we may meet on the way? So what do you can you think of some other functions which we have not seen? Trigonometric functions. Okay. So what is the derivative of, say, cos x or sin x or cos theta, sin theta, and so on? So I'm not going to derive it or something. It becomes complex. But you can ask the same question to all this ChatGPT or MATLAB, and it will answer the questions for all these things. So what I'm going to do is to can you do that? Can you ask ChatGPT what is the, let's see, do that and ask it for sin x, cos x, and tan x. That itself will straight away tell you. I'm going to do that. That's all. So nothing to be remembered if you have a computer. So derivative of sin x is cos x, derivative of cos x is minus sin x. There's no point in remembering all these things. If you don't know, just put it and then you do that. Clear? And we can get it for arc sine, that is sine inverse, cos inverse also. Okay. Now, you can do very complex problems. We are not, because of our arsenal, we are not very worried. We can do complex problems. Okay. So what is a complex problem which we are going to do? Let us see this. Because the function looks complex. So let me get out of this and okay. Now let us see that. It's a very interesting model for world population. World population is 4.4286 to pi by 2 minus. Let's come with arc tan. What is arc tan? That's tan inverse. 2007 minus t divided by 42. T represents a calendar year. 2007, 2008, 2009, and so on. Okay. Right. So find out what is the rate of increase, which we call as P prime at 2020. This is a very standard problem. So something is going on. So what is the rate at 2020? Okay. So this looks very complex. Okay. And so we introduce what is called chain rule. We did that in the last class. So suppose y is equal to e power minus u, where q is equal to x squared. Okay. Now find out what is dy by dx. If I ask this question, I said there is a chain rule. In other words, y now is a function of u, and u is a function of x. So now when I say dy by dx, we said we can write dy by du into du by dx. What we said. So that here e power minus u multiplied by 2x minus. What that doesn't make sense. I think I'll do it here. So dy by du equal to minus e power minus u. Then du by dx is equal to 2x. Remember, we said 2x. This 2 comes here. Then 2 minus 1. So 2x. So both multiplied, it becomes 2x into minus 2x into e power minus u. So this is called chain rule. Here, I have one big function, which is a function of t. So it's a big function. Usually, people will get stunned with it. We are not going to be stunned. Because you just enter ChatGPT, write a code to find out the rate at 2020. At 2020. Right? So you can write out. Is there any questions when you write out? What do you think? Will that be a problem? Let's try it out. Dr. Shanti, can you try it out with ChatGPT?
I've tried.
This kind of problems gives you confidence. No, whatever be it, I'm not bothered. Because many functions in your physiology, which I'm going to take after completing some portions, more examples, will be quite complex. Nothing to fear.
Okay, I think we need to have something else installed
What's
to
happening?
run this code. I mean, the I think on my iPad I didn't get it installed
Oh, iPad. I mean,
because my laptop I'm using for the class.
oh, okay. You can try it out anyway.
Okay.
So it's very simple. So I will. So this is you can try it out. This is straightforward, and I'll show you the code. 1 minute, I think. One second. Okay. I'm here in this computer. Sorry, I had to shift from one to the other. Yeah. I'm going to share screen in the other system. Right? You're able to see my screen? So I'm going to write a code for this, plot the function and the derivative, calculate the value of the derivative at 2020 and display. Okay. So this is what I'm going to now ask it to do. So it's now generating the code. Hopefully it will give me the correct result. So I'm just going to copy the code. Then I'm going to go to my MATLAB. Let me open a new one. I'm going to just paste it and I'm going to run it. Oh. So there's an error. Actually, last time I didn't get an error. Let's look at this. So good. There's an error. So I'm going to now cut and paste this in ChatGPT. I've got a code without an error, but it doesn't matter. Now I'm going to just copy this. Let me check how best ChatGPT is working. So I'm going to paste that straight away and run it. Let's see what it does. Yes. So it is now says that because he's put a dot there to address this, we need to. Okay. Let's get this code. Got this? Yeah. So look what happened. Hello? Yeah, you're able to hear me?
Yes, sir.
Yeah. Right? Hello?
Yes, sir.
Yes, sir. Yes.
You're able to see the plot?
Yes, sir.
See, there was an error. I cut and pasted it. Now it has corrected it. Okay. Now this is the function.
Sir, you're audible, sir. We are able to hear you. You're there.
Yeah.
We are able to hear you.
A Srinivasan. Srinivasan there?
We are able to
Srinivasan.
hear you, sir. We are hearing.
Yeah. So now you get this value. So the value of the derivative, you are getting that here. Okay, and the plot is just now I showed you the plot. So even if there's a mistake, you can correct it. You can put it back and check whether it is correct or not correct. Okay, and this is the point that it is showing. Right. So essentially, whatever you want to do, cut and paste it. If there's a mistake, go back, correct it, put it back, and so on. Okay. Now, I want to check. This is one of the questions which is asked. Let's say I want to check whether it is correct or not correct. Right. So what it is displayed. So it says that it is minus 0.062. Okay, that is what it says. Is this correct value? Is this minus or plus? That's the question. Is this correct value? One of the things which you may get. So let us check whether it is a correct value. Now, how do I check this, whether what I have got is a correct value or not? How do I check it? Whether this is a correct one or not a correct one.
Change it back to its function and see.
Yeah, we can check with that changing the function. We can also look at each of these things, whether this is done correctly, whether I will be able to, I'll get the correct this one. So, value. I have a small doubt here. So this is where it's helpful. Right? So what I'm going to do is, I'm going to ask this question. Write down. So one is, I want to know whether this derivative is correct or not, where this program is done. So what I'm going to do is, I'm going to ask this question. What is the derivative of the function? I'm going to ask that question. Let's see whether it does this. Okay. So now it has given me a derivative of this function. Right? We can implement this derivative in the MATLAB. So this is what it has given as the derivative of the function. Now, if you look at it, will it be negative or positive? Will it be negative or positive? No. What is the? Let me put it like this. So let me put it here. Now, is the result correct or not correct? How do I interpret? Is the result correct or not correct? What is the result it gives? It gives minus 0.09. That's what it says. Is the result correct or not correct?
Since it's a population growth, it can't be correct.
No. Don't answer from general knowledge, from this graph. Because this one question, I'm happy that it actually made a mistake, but this is much easier to look at the result. Josen, Is it correct or not correct?
No, right.
Yeah, hello?
The DP/dt is always positive, right?
No, don't answer from general knowledge. Answer it from this graph, because it can be something else tomorrow. Answer from this graph.
DP/dt is a straight line, so it.
From this graph, what Dr. Shanti said is correct, but interpret the graph and see whether it is right or wrong. See, look at the slope. What is the slope? I'm asking the slope. So, what is the slope? Is the slope positive or negative?
Slope is positive.
Positive. So there is a straight line. So slope is only a straight line.
Yes.
So almost, it's actually not, but almost. But you look at this here. Actually, it is calculated correctly, not 962,235. But when it wrote as negative. But actually, this is the correct value. Say it's put as 0. So you can further refine it and so on. So in other words, what it means is that you have to check. You have to check whether the answer, okay, is correct or not. Actually, this a -1 should be here. So this is actually the correct value. So in other words, what it simply means, you look at the graph, it's increasing. Okay, so it can't be negative. That's what it plots here. But this is the graph. This is the point. So not 96222. Okay. So if whatever be the complexity, we can write a code. We can also check by looking at the result, logical or not logical. Depending upon that, we can also see, or you can run it once more, put a small part of it, whether it is correct or not correct. Then let's look at this. Let's say that this expression is not correct. Let's see what it does. You know what happened? Look at that. You are correct. My apologies for the oversight. Let us correct the derivative. So this is actually the correct expression. It is corrected it. ChatGPT makes mistakes, but if you tell it, then it corrects it. It has differentiated it, corrected it. So you should have a feel. That's all. Joseph, did you see it?
Yes, sir. Second, it had a minus on the first code.
Yes.
Before 4.4.
Yeah. So it left on minus. So then now it is differentiated. I really appreciate it. No, it's a complex function. It's just differentiating and giving you correctly. So in fact, you can ask it to derive. This is the complete derivation it has given. And then it has corrected the code. and then give it. Okay. Okay, let me come out of this. Very interesting. Sometimes, I mean, ChatGPT too makes a mistake. You can't do anything about it. So, okay, I'm not going to take a new lesson today. Now we know quite a bit. We know maximum minima, and we know some programming. We know, we can use ChatGPT for it. We know how to apply it. Now there are very many applications which we are going to see. Maybe I wanted to start something, but since people are not there, let us look at the next level of stuff. Okay. The most famous expression, Joseph, what is the most famous equation in mechanics? Because you have studied that.
Rate of growth of tumor cells, but I'm not sure.
No. I'm talking about simple things what you see in everyday life. F is equal to ma. Right? This is 7th standard physics. Force is equal to mass into acceleration. So what is acceleration? You are accelerating the car. What is acceleration?
Change of velocity over a time period.
So what is velocity?
Distance traveled over a time. Distance, yeah.
So what is this? So what is the relationship between all this? So distance traveled over time. So distance is, say, x. So what is velocity?
X
In our
into
language.
time. X into time t.
No, in our time, you're just now you defined it in English.
Yeah.
It's by T, no?
X by t, but x by t is absolutely correct. But since it is instantaneous, that x by t can change with time. I can have a complex displacement like that. Then how do I define velocity? dx by dt. Right? That is the
Yes,
rate
sir.
of change of x, rate of change of displacement, dx by dt. So how do I now define acceleration?
dv by dt.
Okay, what is dv by dt? Fantastic.
Change of velocity over time. So
Change of velocity. So what did we call this as?
slope of velocity.
Slope of velocity is what? Slope of displacement. So second derivative.
Yes.
Right? It is the second derivative. So first derivative is slope. This is slope of slope. Right? So it is the second derivative. Slope of v. So it is the second derivative. Distance is x. First derivative, second derivative. Clear?
Yes, sir.
So, Dr. Shanti, is this clear?
It's clear.
Yeah. So now you can see f is equal to, now a I'm going to substitute. Oh, it's going to become quite complex. F is equal to m into d square x by dt square. So we are getting into a differential equation. Because differential is there in that equation. We call this as a differential equation. Clear? So we call this as a differential equation. Okay. Now there is what is called momentum. So we can say m is equal to capital M is equal to m into velocity, mass into velocity. So we can see that it is m into dx by dt. So another differential equation. So what is the difference between these two equations? It is the differential that is appearing. Here there is 1. Here it is 2. In another equation can be d cubed x by dt cubed. Something else can be appeared. So 3. So on. So these numbers are called order. So this is called as first order. This is called as second. It's called as third order. Is Srinivasan there? Srinivasan? Srinivasan? Is he there?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. I'm here. Sorry.
Srinivasan,
Yes, sir.
Lakshmi is trying to
Yes,
call.
sir.
Just find out what it is. Any
Yes, sir. I'll do that. Yes, sir.
just call her. Okay. So third order. So first order, second order, third order. This is called differential equation. So what is the peculiarity of this? The peculiarity is that so far we have been given a function, and then we are asking what is the derivative. Okay. Now we are given a derivative, and now we are asking what is the function. So the question is different. I am given a derivative. So what is the function that satisfies that derivative? This is the question we are asking. How do I solve it? Is the question clear? First, I gave a function. So in simple words, first order derivative. So I gave a function and asked you what is the variation of this function with respect to x. Now I'm saying I'll give you a derivative and I'm going to ask you what is a function. So in other words, I gave a function, you are going to a differential equation. I'm now giving a differential equation and I'm going to ask you what is the function. Is that clear? So how do I now solve that? One way is very simple. What is the other way? This is the most important thing in all our applications. Your tumor growth, whatever it is, you define actually an equation with the derivative and you're going to ask the question, what is the function that is responsible? Most important equation. Okay, so that is what we are going to see next. Is that clear?
Yes, sir.
Okay. I think maybe we'll see that in the next class because there's a very important topic. We will see it in the next class. Any questions? So we have to see some implicit function that also we will see it in the next class. Okay. Okay, we'll stop here because there's not many people, so we will do this in the next class. Okay, so thank you.
Thank you very much.
Sir,
Thank you, sir. Thank you,
so
sir.
thank you, sir. Sir, just to give you an update, in the meantime, I spoken to that guy, sir. He had put me in contact with a subordinate, and tomorrow, like he said he will get back to me with the technical specifications and the broad
Okay.
code, sir.
Okay.
Thank you, sir. Thank you.
Sir, and nothing urgent from Lakshmi's end also, sir.
Okay, fine. Yeah. Thank you.
Thank you, sir.